Hello everyone, this is Brad, and we're going through the Oomlaut's Experimenter's Guide for Arduino. This is project number 3, Spin Motor Spin, and in this one we'll be building a circuit to control a motor, its speed and acceleration. And here's the basic circuit design. We're using the Arduino Uno board, pin 9 hooked to the bus here. Pin 9 also has pulse width modulation capabilities, so we'll be able to control the acceleration of the motor. The 5-volt signaling from the Arduino board is sent through a 2.2 kilo ohm resistor to drop the voltage and make it within the safe zone of this P2N2222A transistor. When that signaling is sent through the transistor, it allows current to flow through in a similar way that a relay works, but this is a negative type transistor, so it's wired on the ground side of the motor. So we see here the emitter is wired to ground and the collector is wired to the load. This here is the load coming from 5 volts, which we have down here, 5 volts and ground hooked to over on the Arduino side. 5 volt power here, and that is hooked to this side of the motor, and then the other side of the motor is then wired into the collector. And when the transistor opens, it opens this flow, and then power then can flow from here into the collector and then out the emitter down to ground. So this diode here is set as a flyback diode. So basically when the motor is turned on and it stores energy in here, and then the transistor is turned off, this still has to dissipate energy, and without this diode it would overload this transistor and arc across the switch, whereas this diode does basically what it is designed to do, allows current to flow in one direction. So when the power is then flowing down this way, during the power you shut it off and it won't allow anything to go back this direction and damage components, and it just cycles around the portion of the circuit where the motor is and dissipates and allows the motor to dissipate its current within itself without damaging the rest of the circuit. So we'll plug it in here and hear it just turns on and then off is what the code is set to. There's nothing really to show. Can't really see it, but I believe you can hear that. Okay, and here's the code. This is accessible at ardx.org/code03, and then you just copy and paste it into here. This is for circuit 3. Basically, setup the same. You do void setup and then void loop. This is here, we're defining pin 9 as motor pin, just a variable to use later. We run void setup, set up pin mode, motor pin, which is pin 9, set that as an output. This void setup runs once, and then void loop is our looping, and this first one here, motor on then off, is what I just showed, that turns the motor on and then off and then loops around. This is the motor on then off that is called with this void loop here. On time is set for 2.5 seconds and off time is set for 1 second. So basic programming here, digital write, and then pin 9 set to high, so 5 volts, and then it delays for 2.5 seconds on this, so the motor's on for 2.5 seconds, and then pin down low pulls it to ground, and then that's delayed for a second and it loops around. Okay, now we move on to the Making It Better section of Project 3. This is to explore the controller, or controlling motor speed and motor acceleration. This next one here, I've just uncommented the second loop, commented out the first loop we just looked at, and go down to motor on then off with speed, which is the second loop. Here we've set the on speed is 200 out of 0 to 255 value, and we're going to be using the analog right to take advantage of the pulse width modulation to control the speed. So speed is 200 out of 255, and then the on time is then 2.5 seconds again. Off speed is 50 out of 255, so not quite off but slow, and then delayed for 1 second. And then here again, as I said, we're using analog right to take advantage of the pulse width modulation, and analog right, pin 9, on speed for 200, and then it delays for 2.5 seconds, and then turns off, or selects off speed, which is 50, and then delays for a second. And I'll plug it in, and you can hear it. You won't really be able to see a whole lot, but so now down to 50, and then back up to 200, down to 50, up to 200. And this is the second part of the Making It Better section. We're looking at the third loop here called motor acceleration. And this is calling the loop motor acceleration down here. We've set the delay time to 50 milliseconds is another variable we've included here. This is basically two parts of code. One accelerates the motor and the other decelerates it, and then it, in the void loop, loops back around. This is the for loop counting from 0 to 250, 0 to less than 256, so 0 to 255. Values of I counting up, and then for I it writes a new motor speed every 50 milliseconds as it counts up in I's, so that increases I every step every 50 milliseconds and increases the voltage, so basically creating a somewhat smooth acceleration. And then it does exact opposite for deceleration, so it counts down from 255 down to 0, and then changes the I, which is 0 to 255, and that's the value of the pulse width modulation, and then delays that 50 milliseconds. So you get a acceleration and deceleration. Here, I'll let you hear it. Starts low, and then accelerates, and then back down. Now on the acceleration side of this, electric motors have a starting voltage and current requirement, so the acceleration won't just go from 0 RPM up slowly. There is a required voltage and current to make the motor spin initially, so there won't be any spinning until it reaches that voltage, and then it'll kick on and then accelerate up from there, but it will decelerate down to 0. So that is shown in this motor example.